Hi, my name is Mike Lawrence. This video is one of a set which is intended to provide a different interpretation of the experimental results that constitute the foundation of current physics. It is clear that the present explanation for what we see in the universe is good in many ways, but it is missing an overall coherence. My view is that we need to look at physics with new eyes and consider an interpretation that explains most things well, even if it does question just about everything. I do not disagree with any experimental results, only the interpretation of those results. And I do not say that the hypothesis that I'll be talking about in these videos is the theory of everything, and that everything I suggest is correct, but it is a start. Each video in the set will cover an aspect of physics. The whole set needs to be understood together in combination, because many aspects rely on each other, and any one taken on its own may not be convincing to those relying on the current interpretations, some of whom may actually be offended by the hypothesis. There will be links in the videos to other videos in the set that cover closely related or overlapping aspects. Within the boxes in the videos are representations of the motions of the particles and their composites, which I will be explaining more fully. I'm happy to answer questions where I can, perhaps providing links to where a deeper mathematical analysis shows why I say what I do, since equations and graphs do not make good videos, and will post replies where appropriate on Twitter. I hope you enjoy the videos and they enable you to better appreciate the absolute symmetry and simplicity of nature. But please remember, I'm not an experienced presenter, and although I state everything as if it were correct, this is only a hypothesis. This is video 9. Why gravity appears to be weaker than charge. After eliminating the gravitational constant g and adjusting the Coulomb by the square root of 10 to minus 7, it is clear that the strength of mass and charge fields are identical when the sizes of the creators of those fields are the same. The reason why they appear to have different strengths is because the fields that we observe are generated in different ways. The charge fields that are observed in loops is the total of the fundamental charges of the meons themselves, and their twisting generated 1/6 charges. In every loop, the total of the fundamental meon charges will always be 0, and it is only the sum of the 1/6 twisting charges that is observable, other than in strong magnetic fields where loops are distorted, such as when measuring charged lepton magnetic moments in cyclotrons. The twisting charges are related to the adjusted-Planck charge by the square root of the fine structure constant divided by twice pi. This is a large value, being about 0.034 times the adjusted-Planck charge. On the other hand, the gravitational effect of a loop is due to the motional energy of the meons rotating within the loop, which is the loop mass. This will depend on the loop size, but for an electron will be its mass divided by the adjusted-Planck mass, or about 2 times 10 to the minus 18. The result is that the actions of gravity appear to be much weaker than those of charge, but that is only because it has not before been recognized that the sources of gravity and charge are completely different. One is due to the twisting of the meons, and the other to their rotation within a loop. There is no symmetry breaking, since all energies and forces between meons always can be exactly reversed by swapping the identities of the meons and their twist orientations. So there is no grand unification of forces or energies possible. The only two energies or forces that exist are due to the fundamental meon mass and charge properties in various forms. The asymmetry of loops is what underlies the color force, but color is actually the rotational asymmetry of mass and charge forces acting directly between meons, both within and across stacks in a nucleus. Stacks can include neutrino loops, even in nucleons, because the real particles present are the meons with their adjusted-Planck masses. Charged leptons of appropriate energy can also exist within nucleons, since they also have threefold symmetry, as can photons briefly. The impact of an appropriate energy neutrino on a charged lepton in an up-down-up core neutron stack will overall result in the stack becoming a proton stack and an energetic charged lepton exiting. Technically, there will be an antineutrino entering and exiting with each particle, but the net effect is just that a neutrino replaces a charged lepton. If the neutron stack is instead a down-up-down quark core neutron stack, then other bosons are needed to provide strong mass and charge fields to enable loops to break and swap meon components. The action of a neutrino replacing a lepton in a stack is the physical action that is called the weak force. The strong force is the direct action due to mass and charge, directly between meons in adjacent stacks in the nucleus. The electromagnetic force acts between meons in loops, but is transmitted by the background pairs, forming chains between each meon source and sink, so that, for example, lines of magnetism are real physical structures. Related videos would be 13, what is a double adjusted Planck unit system, and 8, how the gravitational constant hides the equal strength of mass and charge. Thank you for watching.